Hi guys, so my name is Joel and I'll just be walking you through our project SafeSite, developed by Ian Florid, my team partner from the Carnegie Mellon University Africa. Okay, so SafeSite is basically an IoT solution, or rather an AIoT, because there's an artificial intelligence component to it, where we basically developing a solution to protect factory workers and not just factory workers, because the initial use case in the proposal submission was also for miners. Yeah. And how are we trying to protect them is basically through real-time sensing, monitoring, and instant alert communication with the supervisor of either the mine or the floor in the factory. Yeah, so for this demo, I have two recordings. So one is my smartphone, which I'll also be using to show you the hardware, and the other is my laptop PC, which I'll be using to take recordings of the um, web application. So basically, for this project, we use 90% of 90 to 95% of the kit that was provided by Myosa kit rather. And the main communication protocol here is the we use MQTT Mosquito. So to get this started, um, so first thing first, I will have to start the broker, the MQTT broker. So I have to run my command prompt. Yeah. So net start mosquito. Okay, so the mosquito broker is already working. And here we have the code that will be uploaded to the ESP32 board on the Myosa MCU. So the code has already been uploaded. Um, so one thing we now need to do is, so one thing I think I need to show on this edge state is when we're updating the partition scheme is something you have to take note of, because we did not use the default because we're having issues with overflow memory. So we needed more. Instead of the 1.2 megabyte, we used the huge app, which is 3 MB, and this prevents the um, OTA, which we are not using in this solution, and gave us more room, more space. So by default, so let me bring this a bit down so we can. So by default, when the whole hardware is disconnected and I connect it here, it powers up and it makes this buzzing sound. So there are two reasons why it makes the buzzing sound. Number one, the first reason is it's trying to connect to the internet. So I just need to verify if my mobile hotspot, for example, if I open the serial monitor here, you can see it's trying to connect to the internet. Before that, let me stop the broker. So I've stopped the broker. So the first thing, like I said, is trying to connect to the internet. So once you connect to the internet, so I'm coming. So now it's connected to the internet. So the next step is it has to be connected to the MQTT broker, which you can see here is failed, and that's why it's still making that buzzing sound. So when we go ahead to start the broker, yeah, we are all done. So after this, we now need to come to the web app, where we have to firstly go into coming. So firstly, we have to go into the um yeah. So firstly, we have to start the back end. So yeah, after we are done starting the back end, then we go ahead to start the front end, because the front end was developed using React. Let me take this off again. So yeah, we have to go ahead to start the front end. So yeah, so once the front end is live, then we go ahead here to visit the front end. So basically, this is the admin's dashboard, and once the admin logs in, just for authentication purposes, yeah, you'll be able to see the dashboard for all the workers. For in this case now, we have three simulated workers, so the data are just randomized, and this is the data for the hardware. So you can see now it's currently online. So if we go ahead to disconnect, what the system does is after 15 seconds, it's if it doesn't the hardware is not subscribed to that topic, after 15 seconds the status will change from online to offline, which we'll see in a couple of seconds. So you can see now it's currently offline. And this also works if, for example, you are powering it with a power bank. So once we do this, that's the initial sign. It's checking for the internet, checking for the MQTT broker. Then once both are connected, the sound stops, and you can see here now that it's currently online. So from here now, the admin can go ahead to do things like, if you want to check the status of the worker, yeah, you can just click on this, and I'll be showing some demonstration also. So over here we have a push button, yeah, which you can see a tactile push button. We have all the sensors from the Myosa kit. We have a buzzer, then we have the OLED display, and now we're powering it with a power bank. So what I'll first go ahead to do is, so we have cases where um if the user, the worker, wants to notify the administrator of a danger or maybe an hazard, he or she can go ahead to just press the push button, and it will notify on the admin on his or her end. Yeah, so we have that feature. So let's just do that again. Also, it will be displaying on the screen here. So you have that feature, and it keeps a log of all the alert history. So that is one feature. Maybe the user, for example, wants to call the attention to the admin, or the user is stranded in the mine. He or she can use this he or she can use this feature to call the attention of the admin. And another thing that we can also do, so there are situations whereby if the administrator observes the danger, maybe because as a result of danger, another worker has been exposed to, or maybe from analyzing the sensor log, maybe it's the heat or whatever sensor, the sensor data. It can even be the sensor data of the floor. Maybe there's a fire outbreak, and he or she is not doesn't get that. So one thing we can also do is the admin can pick particular a particular worker and send an emergency alert. Yeah. So because I use a simulated worker, but if you now go ahead um to the hardware, which is the Myosa kit, and you send the emergency alert, it is going to make the buzzer sound and also display on the screen. So let me do that again. Um, so yeah, so it can work like that. And we also develop this solution in such a way that you can also send alert to all users. So for example, if you want to broadcast to all users, you can go ahead to click this. So this will be broadcasted to all users, and you can go ahead to send custom messages. For example, if it's a fire incident, or maybe you have codes for whatever it might be, you can go ahead to send this, if you use this feature specifically to the hardware user, or you can send it to all users. So that's one feature that we also incorporated in our solution. And also this keep tracks of all the alerts of, and once it has been verified, we can go ahead to dismiss the alerts. Yeah. So another feature here is the add worker. So we have this feature where it's way easier to add the worker from the front end and not from the code. So though we've not finalized this feature yet, because we need a secondary kit to do this, but we want to find a solution whereby we use this one. So you can go ahead to add a worker. Maybe let's say we are adding Joel, his age maybe 23. Then what department in the factory? Let's say assembly line B, is a technician. Then if you are using the Myosa kit hardware, this is where you input the unique ID that the kit uses to subscribe to the broker. So if you come to the back end here and you come to the at the point where it subscribes here, we have a unique ID. Yeah, and this is what you can use when the kit connects. So this is what you can use when the kit connects to the broker. So you type that here, then you also check that you are using a hardware. So but in this case, we just want simulated data. So we just create a worker, and you can see that we have simulated data in this case. Another thing we also incorporated is you can decide to export your data, exporting your data either as a log in JSON format, or just the alert, or just the sensor data, whichever one you are interested in logging out. So while we open this, one of the challenge and the major challenge or setback we had, which we spent so much time on. So yeah, this is how it says, is the state of the sensor. As you can see, the sensors are currently stationary, but we observe that the gyroscope and the accelerometer keeps reporting data. So there was this tutorial we also on looked at on how to like check what this is and like troubleshoot, and we try to also implement. And when we implemented ours, we saw that the 3D object, because they use a 3.js library to create this, it was just giving erratic behavior. Yeah, so I would like to quickly see if I can show you that. So I'll have to stop the serial monitor here. Okay, so I would like to quickly show you, and one of the plans we have as a team continuing and taking this project further is actually procuring, while this is okay, sorry, I have to reconnect this to the com9. So it's compiling the sketch. The initial program is still trying to run, but while I'm saying that, while that is on, one of the things we intend to do is purchase this a new MPU 6050, so it can verify the assumption that this one is broken. Yeah, verify our assumption that this is broken. So if this is still uploading, so then also in the documentation we also raised issue about power, because we intend to power the whole system, not with a power bank, making it compact. Like, we're going to also 3D print a case for it using this, and this produces 7.4 volts. So we have to get a step down DC to DC converter. The one we have here is a step up, so we could not use this. And when we are able to do that, bring that to 5 volts, we'll be able to power our air quality sensor. This is an MQ135, so we also intend to integrate it into the system. So let's go back to this quickly. So this is done uploading. So let's do this also. Then, so if we come ahead here, if we go ahead to, well, okay, yeah, we copied this. So even after we tried process techniques like sampling and finding moving average, we still realized that the issue still persisted. Yeah, so this is what you can see now. The sensor um, is static, but we keep getting erratic movements. The temperature is pretty fine, confirmed, but we notice that the gyroscope and the accelerometer values are so wrong. Yeah, so I think that will be all for this presentation.